Hey, BCsauce, Gavin here. Have you ever thought about the motion of a particle? But what is a particle? What constitutes a particle? Like this, is this a particle? Or could you be a particle? So what if I told you that a particle's motion in the x direction as a function of time is defined by this equation? And then what if I told you its motion in the y direction as a function of time is defined by this equation? And what if I asked you to find its velocity vector and its speed at time equals 0? How? Well, let's go to the paper. So to find the velocity in terms of t, all we need to do is take the derivative of the velocity function in both directions. And for the y, simple enough, right? But how do we find speed? Because speed is equal to the absolute value of velocity. Speed is a scalar. Speed doesn't have direction like velocity does. So would we just do dy over dx, absolute value? Wrong. See, dy over dx, that's of the derivative in respect to x. We need speed in respect to time. Think about it this way. Say this is your motion in the x direction. This is your motion in the y direction. And when you put it together, the motion of the particle will look something like this. You see that? You notice something? It's a right triangle. And if we know two sides of the right triangle, how do we find the length of the hypotenuse? Pythagorean theorem. See, that's what this is all about. It's just basically one big motion triangle. So to find the speed of a particle moving in two directions, you just do Pythagorean theorem. Now we can find the speed of the particle at time equals 0 the right way. Let's go ahead and plug in our function. Y e to the power of 0 is just 1, so this will become 6 minus 7 squared plus 9 plus 2 squared, which will become negative 1 squared plus 11 squared. 1 plus 121, and our speed for this particle is 122. Now, we're gonna do some more things with this particle, and I brought a few friends along to help. And to help me with the next part of the problem, I brought along my friend Carl.
So, what if you want to find dy over dx? And what if you want to find the limit as t goes to infinity of dy over dx? Well, to do that, we need to define dy over dx. But what is dy over dx? So, to find dy over dx, you do dy over dt over dx over dt. Now, you flip the guy and multiply. So you get dy over dt times dt over dx. And then these two cancel out, and you're left with dy over dx. So, now we just plug in these two, and dy over dx is equal to 9e to the 3t plus 2e to the negative 2t all over 6e to the 3t minus 7e to the negative 7t. And now, once we have this established, now we take the limit of that. So the limit as t goes to infinity of dy over dx. So, let me just write that out. Okay, so as these go to infinity, we have equal powers here. And these two will be going to 0 because these are negative values, which means it's 1 over that e. So we can ignore this part. So these are equal powers, so we take their coefficients. So that's equal to 9 over 6, which reduces to 3 halves. And that's the limit as t goes to infinity of dy over dx.
1.
So, for the next part of this problem, I have my friend Josh.
Hey, and in the next part of this problem, we will be finding the horizontal tangent line. And there is a horizontal tangent line anytime the numerator equals 0. But will it ever? So when finding the horizontal tangent line, we set the numerator equal to 0, so we can disregard the denominator. And when we set the numerator equal to 0, we can factor out a GCF. And that GCF is e to the negative 2t. So when we factor that out, we are left with 9e to the 5t plus 2 inside the parentheses. And now we can set each part equal to 0. So when we set 0 equal to e to the negative 2t, we must take the natural log of both sides. However, the natural log of 0 does not exist. So this is not an answer. So now we'll try and set the other side equal to 0. So when we set the other side equal to 0, first we must subtract 2 from either side. So that leaves us with 9e to the 5t on the right side. And to get the e to the 5t by itself, we have to divide by 9. So we have negative 2/9 equals e to the 5t. And when we try and take the natural log of both sides, the natural log of a negative number does not exist. Therefore, since there are no solutions in the numerator that make the numerator equal 0, there are no horizontal tangent lines. And for our last part, we're joined by our friend Brendan.
So now that we know we don't have any horizontal tangents, maybe there's still verticals. Okay, so vertical tangent lines have to do when the bottom of this is over 0. So we can ignore the top part of this equation. So if you want to know when it's equal to 0, so you just take the bottom, set it equal to 0, and solve. So here we can factor out e to the negative 7t, which would leave you on the inside with 6e to the 10t minus 7. And from here, we can set each part equal to 0. So you'll have e to the negative 7t equals 0. And you'll have 6e to the 10t minus 7 equals 0. For this part, you need to take the natural log of both sides to isolate t. And this doesn't exist. The natural log of 0 does not exist. So this cannot be an answer. Now for this, to solve for t, first you have to subtract or add the 7 over to the other side. Divide by this 6, and that'll leave you with e to the 10t equals 7/6. From here you take the natural log of both sides again, and you'll have 10t equals the natural log of 7/6. Then you just divide the 10, and your answer is t equals the natural log of 7/6 over 10.
And as always, thanks for watching.